This video is an example projectile motion problem. A soccer ball is kicked at a 25-degree angle with the ground at 20 meters per second. How far did the ball travel along the ground? How high did it travel? How fast and what angle did it impact the ground with? To begin with, I'll draw a little picture. So here's my stick figure picture. And 20 meters per second is initial velocity at 25 degrees. And I went ahead and drew what it's going to land at, which is negative 20 meters per second, 25 degrees. And I know that because it's going to land at the same height that it takes off from, so there's a bit of symmetry to this problem. Then I'll make my table of givens. So I've got my Vox TVA, VOX TVA, and I'll have a vertical and a horizontal components because I have two accelerations. One acceleration is vertical, that's gravity, the other one's horizontal. And now I'll put in the things I always know are true without even reading the problem. I know vertically, the acceleration due to gravity is going to be 9.80 meters per second squared going down, and horizontally there won't be an acceleration, so I'll put a 0 in there. Now I'll start this problem by drawing out my initial conditions. So I've got my initial velocity, that's my 20 meters per second, and then I'll draw its components. So I'll make a triangle, so the components add tip to tail to give me my final answer, and in the corner down the lower left, that's going to be my 25 degrees. Now I need to define the length of my two red vectors, so my horizontal vector will be basically the hypotenuse times the adjacent function, so that's cosine 20 meters per second, 20 meters per second cosine 25. Make sure you have units on your 20 meters per second because those two things are a set and they go together. Vertically, my initial velocity is going to be 20 meters per second sine 25. Alright, so now that I've defined these, I can put them into my table, into my vertical and horizontal column. So into my vertical column, I can put in my 20 meters per second sine 25, and in my horizontal, I can put 20 meters per second cosine 25. So now I've got my units in there, all set, and I've got an arrow just to help me remind me some of the directions. Next, I know that because the acceleration is 0 horizontally, I know that's also going to be 20 meters per second cosine 25. But we're probably never going to use that, but I'll go ahead and fill it in the table anyways. Vertically, when it lands, because it's landing at the same height it takes off from, I know that it's going to be an opposite direction of the initial velocity. So vertically, instead of going on the way up, it's going to go on the way down with the same magnitude, that is negative 20 meters per second sine 25. So there's my vertical component when it lands. And because, as I've been saying, it lands at the same height it takes off from, vertically, my displacement between the beginning and the end of my motion is going to be 0 because I land at the same height I take off from. And what I'm looking for is the first question, how far along the ground or did it travel? So I'm looking for that value right there, which we call the range. So the nice thing about the range is since there's no acceleration, there's only one equation that we know of that'll work. And you might have had this in Algebra 1 class as the distance equals rate times time equation, or we'll call it range times velocity times the time in the air. So if I look at this, I'm looking for the time in the air in order to solve this question because I already have VXO, that's the that's the horizontal initial velocity, which is 20 meters per second cosine 25. So I need to find the time in the air. That means I can find the time using vertical or horizontal givens. I don't have enough horizontally in this case, but I do have enough vertically to find the time, and then I can copy it over into the horizontal column. So using my vertical givens, I'm going to use those to find time, and I'll use the V equals V naught plus, and I'll use GT instead of just AT. G because I know that the acceleration is due to gravity, so that'll be the 9.8. And then I'll rearrange this for T, so my time in the air is the difference in the velocities divided by G. Throw in my numbers. Notice that my final velocity is negative. If you don't put in a negative, you get 0 over 9.8, and that's not going to work. So I've got to put in my negative value. And that'll give me my time in the air to be 1.72 with all those decimals. So that's the time in the air. I can fill in my table with those two times in both spots. Now I can find the range. So the range is going to be the horizontal velocity, 20 meters per second cosine 25, times the time I just calculated. And I get my range to be 31.3 meters. So that's how far horizontally across the ground the ball traveled. Next question is how high did the ball travel? So I really need a new set of givens for this one because I'm not talking about the motion from start to finish. I'm talking about just partway through the motion to where it reaches its maximum point. So I'm talking about that little point up there where the red star is. And we have a name for that in the highest point. That's the apogee. Apogee means the farthest away from the starting point. For us, it's defined as where our velocity is going to be 0 and where our height is going to be a maximum. that's going to be at apogee. So using those definitions, I can fill in a value on my table vertically. This time I know my final velocity is 0. So last time it was the total time in the air, and this time it's only the time to where I'm at the highest point, so it's a different set of givens. And I'm looking for how high it traveled vertically, so I'm looking for whatever in that space. So I can answer this question with my vertical givens because I have 3 of my unknowns. So to do that, I'll use my Vy squared equals Vy naught squared plus 2Gy. I'm replacing my A and my X with G and Y because I'm talking about motion going up and down. I'll solve this for Y and throw in my numbers, and I'm going to get my answer. I get 8.45. So 8.45 is the maximum height that the soccer ball is traveling, 8.45 meters. On to the last question. How fast and at what angle did it impact the ground with? Well, this is an easy question. Because it lands at the same height it takes off from, there's symmetry in the projectile motion problem. So what I know is, I know this, that it's going to land at the same speed and the same angle, just going down instead of up. And in fact, when I did my drawing, just out of instinct, I went ahead and drew what's going to happen when it lands at the same height. So knowing this, I could do the answer without any math, is 20 meters per second at an angle of 25 degrees with the ground.